So first thing you see here is 4 MTLS compressors, 1 to 2. So this is your heat of compression from your compressor, as you can see over here, 1 to 2 on our enthalpy diagram. And now we're up, and as you can see, in the supercritical fluid zone, or our transcritical zone. Anytime we're above 87.8 or 31 degrees Celsius, we are in our transcritical zone. There is no pressure temperature relationship. Super cool, super unique to CO2, because our temperatures outside are everywhere can get above 31 Celsius or 87.8. From there, we go into something we call our gas cooler condenser. We call it a gas cooler because when we're in that supercritical fluid zone or the transcritical zone, there's no pressure temperature relationship, and we're just cooling the gas. We're not condensing. We're just cooling the gas. So as we go through there, we're rejecting the heat. We go into what we call our high pressure valve. Something very unique about CO2, we have these high pressure valves, which reduces the pressure from this high, like 1,000, 1,100, 1,500 PSI, all the way down to 500. So that valve is like a metering device, but it has other functions as well. When we're in a subcritical zone, just say 2 here, only goes up to 900 PSI. When we go across for the heat of rejection, we get in now into the 2-phase zone. We're in subcritical. Now we can start to condense. So that valve now is monitoring subcooling. So it's maintaining maybe 3 to 5 degrees subcooling for that system. And the other function for this high pressure valve is in the middle of winter, it acts like a holdback valve to fill up the condenser so it can continue the mass flow. From 3, we go to 4. So through that, we have that pressure reduction from, say, 1,200 PSI down to 500 PSI. Say we want to maintain that receiver, flash tank receiver, at, say, 32 degrees Fahrenheit. What we do from there is we take the liquid off the bottom of that receiver and send it to both the medium and low temp system, which is really cool. So that same liquid, good quality liquid, going both to your medium and low temp devices. The only difference is our medium temp only reduces the pressure down to, say, 20 FSST, or down to, say, around 400 PSI. And then that goes back to the medium temp suction. Where the low temp, you'll reduce the pressure even more. So that's the same liquid coming into the valve. Say it's 500 PSI coming into the valve, but it's just dropping the pressure more down to around 200 PSI, we'll say, around minus 20 SST for the low temp. Then let's jump back up to the top. So now you see a line going from the flash tank receiver to a valve that is called the flash gas bypass valve. And this valve is very important. And the high pressure valve and the flash gas bypass valve work hand in hand. They work together. So this bypass valve now is bypassing gas to maintain a nice quality liquid in that receiver, good pressure. So we're feeding good liquid refrigerant both to the medium and low temp systems. So we bypass that back into the medium temp suction, and then we have our compression on our ZO scroll compressors, and we discharge back into the medium temp compressor. Super cool, super unique to CO2. This is definitely the basic booster cycle.